Alright, we're going to practice, and I'm erasing here because I messed up one step on the problem on the bottom, and I put it all on one video. The rest of this is just going to be one video. So I did a dividing wrong, and it messed up my whole problem. I hate when that happens in real life, but even worse on camera. So I'm going to start this over again. On the last video, we talked about many or no solutions based on when you're done, all the variables are gone, and it's true or not true. And we're probably going to see one of each right here. So my first step would be to solve one of these for a variable. This one's really easy to solve for x. So I add 7y. I got x equals 7y plus 14. And then I'm going to do my second step, which is just to plug that in. So if I take out this x here, so I would write negative 2, and my x is going to go in that parenthesis. I write the plus 14y equals negative 28, and in here I write 7y plus 14. Kind of hard to read, but it's in there. If I distribute through, negative 2 times 7y is negative 14y. Negative 2 times 14 is negative 28. That 14y comes down. And we can see that the 14 and negative 14 and cross off, and I get negative 28 equals negative 28. Well, there's one. We know that's true. So they're the same line, and we have infinite. We switch these. Solutions. Alright. So this is probably going to be the other one. Sorry, it's messy in there. Let's see if I can use a good amount of space and make this a good bit neater. So step 1, solve this guy for y, right? Or this guy for y. Check that out. If I just add 3x, 3y is 3x plus 12. And then for step 2, I'm going to plug that y in down here. So I'm going to say 6x plus 2, and I'm going to give myself a good amount of space to plug my y in as I break my pencil, equals, what is that, 18? And my y is 3x plus 12. Alright. Well, that's supposed to be a minus 2, isn't it? 6y minus 2. Alright. When I distribute, I've got 6x, distribute through, negative 6x, distribute through, negative 24 equals 18. These x's cancel out. I get negative 24 equals 18, but it does not equal 18. So it is false. This would be those parallel lines, and no solution. There it is. Alright, so we're going to show one of these down here. Alright, so I'm going to go through and we're going to show you how this is done on a word problem. This one talks about high-speed internet providers. Alright, A has a $100 setup fee and costs $65 a month. And we can see that is right there. Okay. You have an option to go with provider B that costs you $30 to set up and $70 a month. So one costs more to set up, one costs more in a month. Alright. So what if we substituted this first term, 100 plus 65m, for t in the second term? So I take that t out and I write 100 plus 65m. And when we go there and we subtract 65m from both sides, so I go minus 65m, and our goal is just to solve for m, right? Minus 65m. That would give me 100 equals 30 plus 5m. And in the want to solve for m, I could subtract 30 from both sides. Well, that would be 70 equals 5m. If I want to solve for m, I could divide both sides by 5, which gives me m equals, how many times it go in? 14. Okay. And we're going to continue on the other side. I'm going to come over here and write m is 14, because somehow I got a 6 the first time. No clue. No clue how I got that. So, what if I plug that 14 in? What if I come over here and say, hey, let's plug in 14. 70 times 14 plus 30 is 1,010. And my solution right now is going to be 14 months for a price of 1,010. And that really is about what it costs, over $1,000 a year, depending on where you go. Both internet providers will cost $1,010 after 14 months. All right. If the variables in a real-world solution represent the number of months and costs, why must the values of the variables be greater or equal to 0? Well, that's a really good question, right? Because we basically can't have negative months or time in this case, but months. And really dollars, they're not going to charge you negative dollars, it's not going to pay you. So you want to be greater than or equal to 0 on most of these. So we got a couple more. Let's try this guy right here. All right. We got a boat that travels 18 kilometers per hour from its port. All right. And a second boat travels 34 kilometers per hour behind the first boat. All right. The second boat is 34 kilometers behind the first boat when it starts traveling the same direction at 22. All right. Let P represent the boats from the port in the kilometers, and R represent the amount of time. So what we got is, and I'm just going to draw it real quick. We got, let's say we got a little boat. All right, well, we'll say this is my little boat. Not the best drawing of a boat. It's heading this way at 18 kilometers per hour, and then 34 behind it. 34 behind it, there's another boat, right, that's traveling 22 kilometers per hour. So this guy's got a head start of 34, but this guy's traveling faster. All right. So look, the slower boat is 34 kilometers in front of the faster boat. So this guy's going to catch up as long as they're going in the same direction. This guy's got a good lead. All right. So it's going to ask us how long. Let's see what it asks us. How far will the boats be from their port, right? Probably when they catch up. How many hours will it take the second boat to catch up to the first boat? So we have a system here. We want to find out when the total miles is true. The total miles of D equals 18 plus 34 is equal to D equals 22. Oh, that's 18T, right? 22T. So this one's solved for. Step one's done. So I'm going to take out the D right here. I'm going to put 22T. This D goes in right there. And we write the rest of it. Equals 18T plus 34. We subtract 18T, we get 4T equals what? 34? We divide by 4. Well, that doesn't go in pretty, but it does go in about 8.5 times. So my time is 8.5 hours. Now to find out the distance, I can just plug my time in right there, right? So distance equals 22 times 8.5 hours. And my distance in this case is, I think that's about 187. So if we answered that, we could say, hey, at 8.5 hours, right, they both gone 187, I think it's kilometers, and then they're equal. All right, there it is. Real quick, given a system, how do you decide which variable to solve for first? I would say generally, lowest coefficient is what I would do. How can you check a solution without graphing? Substitute values into both equations, right? Explain how you can solve a system by substitution. Well, we've got our notes. 1, solve for y or x. 2, substitute and solve for one variable. 3, use known variable to find unknown. We're going to once again do that through substitution. It really is a three-step problem. All right. You guys have an awesome day. I will see you soon.